Observe the deposition of this G-tack root pass. Visually, the fusion is flawless, and the bead profile is perfectly consistent. Under industrial codes like ASME or AWS, this physical quality is only 1/2 of the requirement. For the joint to be accepted in a production environment, it must be supported by a specific, interlocking chain of paperwork. Many professionals struggle with the distinction between the theoretical procedure, the metallurgical proof, and the qualifications of the personnel. This documentation forms the triad of welding compliance, the WPS, the PQR, and the WPQ. To understand how a joint moves from an engineering drawing to a code-stamped reality, we will trace the legal and metallurgical sequence used to validate a procedure, map its variable thresholds, and define the limits of operator certification. In these environments, quality assurance is established long before the first production arc is struck. The process begins with a proposed set of instructions, the Preliminary Welding Procedure Specification, or PWPS. This serves as the starting recipe for the joint. This recipe must be physically proven by welding a precise test coupon using those proposed parameters. That coupon is then subjected to destructive mechanical testing. Here, the steel undergoes a guided bend test to verify its internal fusion and ductility. It also faces transverse tensile pulling to ensure base metal yields before the weld metal does. Once the coupon passes, the results are documented in a procedure qualification record, the PQR. This is the permanent legal proof that the procedure works. The PQR captures the exact, actual parameters used during the test. If the welder ran the coupon at exactly 120 amps, the PQR records 120 amps rather than a target range. Once certified by the manufacturer and the authorized inspector, this record cannot be altered or revised to fit a new application. The PQR proves the metallurgy of the procedure, independent of the manual skill of the welder who performed the test. Using the PQR data, the manufacturer then authorizes the Formal Welding Procedure Specification, the WPS, which is the document used on the shop floor. At this stage, the PQR data point expands into permitted operational ranges. That 120 amp test result might translate to a WPS range of 90 to 150 amps, providing the welder with necessary flexibility during production. If a procedure needs to change during a project, the governing code dictates the response based on how that specific variable is classified. Non-essential variables are parameters that do not impact the physical properties of the weldment, such as a minor shift in travel speed. Adjusting these requires only a paperwork revision to the WPS. Essential variables are parameters that dictate mechanical integrity, such as the base metal P number or the welding process itself. This AWS D1.1 WPS Essential Variable Checklist shows thresholds for process parameters and filler metals. Changing an essential variable beyond limits requires an entirely new PQR test. Further down, supplementary essential variables activate when the code mandates toughness testing, turning flexible parameters into strict limits. Identifying these variable thresholds prevents a minor administrative change from turning into a mandatory physical requalification. While the WPS handles the procedure, the Welder Performance Qualification, or WPQ, proves a specific individual can execute it. Welding the PQR test coupon does not automatically grant a welder WPQ status. The two certifications are separate and require different validation methods. Because the WPQ is a test of manual dexterity, it is typically verified via non-destructive testing. This often involves radiography or ultrasonic testing to confirm the operator deposited sound metal without subsurface defects. The WPQ restricts the operator to the exact process, base metal thickness, and physical position, such as a 6G pipe angle, demonstrated during their test. A certified welder is legally restricted from welding outside the parameters of the specific active WPS, regardless of their general skill level. The WPQ is a highly constrained, parameter-specific operational license that applies only to the conditions proven during the test. Under code rules, a WPQ expires if the welder has not utilized that specific process for a period of 6 months. Qualification is also bound to the employer. If a welder changes companies, the new employer must either administer a new test or validate continuity records to maintain the qualification. This welder summary table allows QA/QC departments to track the most recent maintenance date. This is how auditors verify compliance with the 6-month continuity rule across a workforce. Furthermore, these qualifications do not cross codes. A documentation package validated under ASME Section 9 for pressure vessels cannot be used to satisfy AWSD 1.1 requirements for structural steel. This administrative continuity is just as legally binding as the metallurgy of the joint itself. The compliance triad relies on three components. PQR is the metallurgical proof, WPS is the authorized instruction, and WPQ is the license. Changing an essentials variable breaks the proof, while a process lapse breaks the license. Either failure instantly triggers a stop work condition. When all three documents are aligned and present at the workfront, the result is a legally compliant, code-stamped production part. In code-governed fabrication, quality is engineered into existence through the rigorous, unyielding discipline of procedure qualification.